today is how to speed your Revit MEP point cloud modeling by up to 7 times. Thanks for joining us. My name is Kevin Corbley, and I'll be your moderator for today. I'm the Editor-in-Chief of Workflow 4.0, the newsletter of 3D documentation, tips, tactics, ideas, and opinions. We have a content-rich webinar for you today. Through a series of case studies from beta testers, we're going to be seeing how ClearEdge 3D's new software, EdgeWise MEP for Revit, provides a time savings of up to 85% compared to traditional as-built modeling workflows in Revit. We'll also hear from Autodesk's Kyle Bernhardt about the forward direction of Revit and the Building Design Suite. Let's take a quick look at today's agenda. We'll be hearing from beta testers and watch a live demo. And our first case study will feature Bowman Consulting. And the second case study will be from Kelly Cohn of the Beck Group, who used the software on a recent project. And he's got some interesting observations about the results. And then we'll bring on Kevin Williams from ClearEdge. He'll be doing a live demo for us of the EdgeWise MEP for Revit. And then finally, we'll wrap up with your questions from the audience, and we'll pose those to our panel. And we'll bring on Kyle Bernhardt for that Q&A session. And let me run through a couple of housekeeping tips right now. And for those of you unfamiliar with the GoToWebinar interface, you can ask questions and you type them into the question window. You should see a little question box there. Just go ahead, open that if it's not, and you can send us a question at any time during the presentation. However, we are going to wait till the end during the session to take those questions. So feel free. Also a reminder, we are recording the webinar, and at the end you'll receive a follow-up email with the link to the recorded version so you can listen to it later or maybe even forward it on to a friend. And also, hey, subscribe to Workflow 4.0. That's our new e-newsletter. You'll learn about a lot of things, and we hope you'll even take part in sharing experiences, opinions, and best practices. All right, and let me take a quick second to introduce our panelists today, and I'm going to ask each of them really to introduce themselves. First is Kyle Bernhardt. He's a product line manager for the Building Design Suite at Autodesk. Hey, Kyle, tell us a little bit about yourself. Kyle, you might want to unmute yourself if you're muted.
Sorry, I've muted my phone, but not on the GoToWebinar. So hello, everybody. I'm glad to be participating in this today. As was mentioned, I'm with Autodesk. I work within the Revit product management team. I've got ownership for the Building Design Suite and also kind of do dual duty for the point cloud functionality inside of Revit amongst a number of other capabilities. So I've got a background in mechanical engineering and worked in industry before I worked here at Autodesk, and I kind of play a utility infielder role within the Revit organization, so I can probably field most questions and look forward to hearing everybody's feedback today.
Excellent, thanks. And Kevin Williams, the Chief Scientist for ClearEdge 3D. Kevin, give us your quick bio, and don't forget to tell us about some of your favorite dangerous hobbies.
All right, sure. So my name is Kevin Williams, and I've been working with point cloud data for an awfully long time now. I'm starting to feel like an old man in this industry. Way back in 2000, I worked for a large defense contractor and developed the very first commercial software application capable of automatically extracting building models from airborne LiDAR data. And since then, I've stayed in the field and kept developing data applications for a number of years until leaving in 2007 with another scientist to start up ClearEdge 3D and go to work on ground-based laser scan data. Ground-based data turned out to be a whole lot more challenging from a mathematical and algorithmic standpoint, just because it's fully 3D instead of 2.5D. But we've come a long way since 2007, and I feel like there's almost unlimited potential for what you can do with ground-based data. So it's a real exciting field to be in. I love working with this data, and it's exciting to see the industry starting to benefit dramatically from this new automated feature extraction technology. I think it's a real game changer for the industry. Yeah, I like rock climbing. I've been rock climbing since college, and it's a lot of fun. I'm stuck on the East Coast, unfortunately, right now, though. We were just talking about that before this webinar. So the vast majority of my climbing these days is inside at a local climbing gym, but that's part of living on the East Coast.
Yeah, well, and I'm glad to hear that you haven't started climbing up the sides of buildings to take place of real rocks. So that's all right.
Yeah, don't give me ideas.
Okay. Hey, Kelly Cohn, you were the Innovations Director for the Beck Group, and tell us a little bit about yourself. I think you need to unmute yourself, Kelly.
Sorry, didn't realize I got muted again.
Yep.
So yeah, I've been with Beck for about 6 years since graduating with a master's in architecture, so that's kind of my background. Came on board Beck right as we started implementing Revit, took over that implementation, and have been running it across all of our offices, and just generally BIM implementation, including several other softwares the last couple of years. We've been working with laser scans for probably the last 4, I've been involved with a bunch of different software vendors to try and get the different AEC products to really latch on and leverage it properly. So I'm really happy to be here today talking about this product.
Okay, thanks, Kelly. And just another quick shameless plug for our Workflow 4.0 newsletter. We have a great forward-looking profile of Kelly in our first issue, and again, at the end, we'll give you all a chance to join up and subscribe to the newsletter. We're hoping to have Mike Stice join us. He's with Bowman Consulting. Right now, he is having trouble dialing in, but we're moving forward. Hopefully, he'll be able to join us. If not in the middle, then by the Q&A at the end. So that is our lineup of speakers, and we know you're going to learn a lot today on the webinar. Here's some highlights you can expect to walk away with. You're going to discover the latest techniques and tips to speed your scan to build Revit as built workflow, and you're going to see EdgeWise MEP for Revit for the first time in the demo, and you're going to learn how that will fit into your MEP modeling workflow. And you're also going to learn how the Beck Group, Bowman Consulting, and others are integrating new tools and technologies into their product deliverables. And finally, during the Q&A, you're going to hear firsthand from Autodesk about how they're integrating new technologies and features into Revit for as-built modeling. All right. Well, this slide says it all. Context is king. And so at this point, I want to ask Kelly Cohn to come on and kind of set the stage for what we're going to learn today. Kelly?
Thanks. So we've been, I mentioned earlier, we've been using Revit for about 6 years and been really in depth with laser scans for about 4. And we were very happy when Kyle and Autodesk first integrated point clouds actually into the platform and allowed us to at least view them. But anybody that's used point clouds in Revit knows that it's a pretty limited functionality in terms of what you can do with them. It's very early on in terms of its integration with the platform. But it puts us in a bit of a tight spot when it comes to modeling as-builts. We are continuously getting requests from clients for models, particularly of their existing structures when we're designing any new renovations inside them. And it takes a pretty significant amount of time to take a laser scan in Revit and actually model all of the as-built components. And it's the slide says firms are in a difficult position balancing services and margins, and it's definitely a challenge for us. I think the owners want something, but they don't realize how expensive it is to actually deliver. And we get a lot of sticker shock when we show them this, and it definitely is a negotiating point for us on our project. So, anything that we can find to improve our productivity going through this process of generating intelligent models from laser scans is a pretty big deal for Beck at least.
Okay, great. And I think that's a great way to start us off. And what I want to do at this point, we're going to have the Bowman Consulting case study, and again, Mike is not on yet.
No, I'm here. I'm here.
Oh, Mike, you're on. Great. Hey, that was good timing. That's terrific. Well, you know what, Mike, why don't you very quickly introduce yourself to the audience?
Okay, appreciate that. Glad to be here, folks. Mike Stiles, and I oversee the laser scanning GIS efforts here at Bowman Consulting. We're a multidiscipline firm. We practice laser scanning on everything from our conventional survey to vertical structures, transportation, mining, you name it, we've done it. And Kevin, I am probably the older person. I think I got you by a little bit here and probably seen a few more point clouds. We're very excited about this new development with the ClearEdge software. And in a little bit, we'll be talking about a project that we're working on.
Great. And you know, go ahead. You've got the floor now, so let me advance the slide. And you can go ahead and start telling us about your project.
Okay. Well, as you can see, we're spread out across the U.S. And we do apply our laser scanning almost to every discipline that we have here. So we're pretty proud of ourselves in that we find those niche projects with each discipline. We're tied in tightly with the survey group because, of course, as most of you know on the phone, the point cloud's only as good as your survey control. So moving on to this next slide with a parking structure in particular, you'll see a project that was about 187,000 square feet, 2 levels of parking. And a lot of the work here up in Northern Virginia is refurb work. Contractors and architects are teaming together, and then they hire folks like us to come in there and help them tie their new design to an existing condition. And with the Revit product out there, that's becoming our conventional deliverable at this point. So with this project, MEP was of prime importance as ceiling heights and ramps were going to be changed. So the quick statistics on the project, we had a couple of folks out there, 78 scans over 3 days. The Regal VZ400 with the photography has always met our expectations time and time again. It's a durable instrument and it works real nicely with these types of products like ClearEdge. The old way we would do this, right now we're looking at that point cloud with the photos. The old way to do that would bring that into a CAD application and model that piping, and in other words, scan to CAD, and then exporting that to get into Revit. We would lose all that modeling and we would just get the center line, and we'd end up modeling that all over again in Revit. And that became particularly difficult and a budget killer when the project started off as a CAD deliverable, but then the architect in the 11th hour wanted a Revit deliverable. So not wanting to hear maybe the explanation or the excuse, we would have to remodel it, and it would kill the budget. So with this new ClearEdge product, I couldn't be more excited about what I've seen so far on this recent project. And you can see some of the statistics up there on the screen. I don't need to read those for you, but basically we were able to import our auto-extracted pipes into Revit directly and proceed right into our final deliverable in about I would say a six-time efficiency enhancement. And I know we got a lot of ground to cover here, so I'd be happy to take questions at the end of this webinar. And here's a quick example that shows some of the piping that was auto-extracted and modeled, and you can see it's inside Revit. And it was a one-step process as opposed to a 3-step process. So just again, I'm very excited about this new development, and I'd be happy to share our experiences with anybody on the call.
Okay, that's great. Hey, Mike, appreciate that. And see the slide on screen right now kind of summarizes everything about the time savings that you all had. 42 hours in the new workflow versus 280 in the old one. That kind of says it all, doesn't it, Mike?
It does, and those are real numbers. I was very happy from a budget management standpoint on this one.
Okay, great. And just a quick reminder to the audience, we will be taking questions, but those will come at the end, but you can send them in at any time. So as you think of them, just go ahead and type those into the question window. And next, what I would like to do is I'd like to bring Kelly Cohn back on from the Beck Group. And Kelly also has a case study to tell us about.
All right, thank you. So, you know, you're going to hear pretty much the same story for me as you did for Mike. It's a pretty dramatic change for us just looking at another case study project. So the Beck Group, just a quick little forward here, you know, we've been in business for 100 years now, family owned and operated. We do full service design, construction, development, and we actually have a group that writes our own software, not in the laser scanning space, but in the estimating space, actually. And so we're, you know, we definitely try and get out there on cutting edge technology on a regular basis. So in terms of our use of scanning, just to kind of give people a sense of scale, we do you know, a couple scans every month. All of these are in support of our construction or design projects. We don't do any consulting work on scanning. And we do all the modeling in-house as opposed to having service providers like Mike do the modeling, because we're really looking to get building information models that we can use downstream in the field for various different purposes. So it's pretty important to us exactly how the model is built. It gives us a little bit of a different perspective on this than a lot of the service providers that we work with. So go ahead and hop on to the next slide here. So this case study project that we looked at was not actually an MEP example. It was a structural example for us. This one came up really a couple weeks ago, and Kevin and I had some conversations about the product. And you know, I saw the laser scan that we got on this project and immediately gave him a call. It's about 50,000 square feet of structural space frame, and we had to kind of crunch this thing through pretty quick for the actual deliverables on the project. We're doing integrated design and construction on this mall. Go ahead and hop to the next one. And you can get kind of a sense of the project. These are the final images out of Revit that you're seeing right here with the space frame. And our use case was pretty limited on this one. It was really for design coordination and documentation. If we'd been, you know, wanting to work with structural engineers to do analysis or things like that, we'd have to be a little bit more particular how these were created. And you can see here the laser scan overlaid on that Revit model. So let's go ahead and hop through this slide. Go to the next one. All right. So, you know, this was just to kind of run through our first pass at this. Was going on at the same time that I sent the PCG file to Kevin. You know, we ran through, took about 80 man-hours to manually draw the entire space frame, and we did it using an adaptive component, which allowed us to move through much quicker than if we had actually used the kind of out-of-the-box structural framing that comes with Revit. So 80 man-hours is really about as fast as it can be done in Revit. And there's some, you know, there's some potential issues with this method. You know, we're really kind of eyeballing in Revit to match it up to the scan. It's not perfect by any means, but and you can see from the images we did a pretty good job of it. You know, so there are some QA/QC potential issues with this process. And, you know, there's some upsides, though. The model elements are at least structural framing category, which is good for documentation, and we can visually compare the scan and the model, which, you know, is always good for us. Now, this is the image straight out of EdgeWise, and what we've got here is all of the auto-extracted pipe from this scan from this section of space frame. To do this entire project, you can kind of hop to the next one. To do this entire project takes about 30 minutes just to kind of auto-extract all the pipes. The thing that we're trying to work out right now, workflow-wise, is whether it's better for us to kind of clean all that up and get everything connected in EdgeWise, or to just bring the raw export into Revit and clean everything up in Revit. I don't really have an answer right now. I think we're looking at doing it both ways and kind of tracking hours still. But it's, regardless of which way, we think it's going to take us roughly an additional 8 hours to complete this. And, that's a pretty dramatic reduction from 80 hours for us. And we get all the benefit of the QA/QC tools that come built into EdgeWise for MEP for all these pipes, which is something that we don't get out of the Revit process. But we do have a couple things that pop up that are things that I know Kevin's working on, and I'll let him talk about that as he gets to his demo. But right now, everything is coming into Revit as pipes, which is a challenge for us, if we're trying to use these things for analysis. And then we don't really get to see the laser scan superimposed on the pipes in Revit because there's some issues with bringing them in and having them just line up right now with how Revit handles coordinate systems. So end result looks the same. It works for us, which is, fantastic. So go ahead and hop to that last one. Because, again, this one kind of says it all. That should say 8 hours. Sorry about that, guys. That would be my typo. So 8 hours versus 80, that's pretty dramatic.
Okay, great. Hey, Kelly, appreciate those tips. And now what we're going to do is we're going to move into the live demo phase, and I'm going to hand control over to Kevin Williams, and he is going to run us through a live demo. Kevin, take it away.
Oh, I was muted.
Yeah, sorry about that. Go ahead, Kevin. You've got the screen now.
Okay, excellent. All right. All right. So I'm going to assume that the majority of you guys are already somewhat familiar with how EdgeWise processes pipe models. So I'm going to go over the EdgeWise component fairly briefly so we can get to the Revit integration, which I think you guys are most interested in at this stage. So, but I will give you a quick overview of how EdgeWise works. So I'm inside of EdgeWise. I'm sorry. I'm inside of EdgeWise right now, looking at just a real small single scan of a small MEP room. But this will give you a good flavor for what the workflow looks like. The real magic of EdgeWise lies in this functionality right here. I'm going to process the scan and use automated feature extraction technology to analyze the points and find regions of cylindrically shaped clusters of points, and the software will automatically detect those and extract pipes and do a least squares best fit of a cylinder to those regions of points. So the idea behind all of our technology is we want to get the computer to do as much of the heavy lifting, the manual, tedious stuff as possible, and let your CAD technician do what he does best, which is analyze the data and make intelligent decisions on the more complex portions of the modeling. So the software processed this file. Let me add in the model that it just created. All right. So these are the pipes that the software automatically detected, and you can see that it got most of the pipes, but it didn't. You can find some missed regions of pipes in this data set. Now, what we found out early on was that automation is never 100% perfect, and so you've got to have an efficient way to go through and QA the data set to make sure that it extracted things correctly. Make sure you don't have any bad pipes. For instance, I just found it here. I know in this data set it extracts a ladder rung as a pipe, and that's obviously incorrect. So we spent significant amount of time going through and building a fairly sophisticated set of QA tools for analyzing these pipes, and we've incorporated them all in our Smartsheet technology here. And this allows you to query each pipe let me zoom out a little bit. Let me turn off the point cloud so we can see a little bit more clearly what's going on here. If I query one of these pipes, it gives me a whole bunch of information. It tells me the length, the diameter of the pipe, the root mean squared error of the fit, the amount of coverage of the point cloud around that pipe. So it tells me a lot of information about that pipe. Additionally, if I turn on the inspection mode, I can click on each of these lines in the spreadsheet and it will jump me to each of these pipes individually. If I rotate around, you can see the points that were used to fit that pipe, and it'll jump me to the next pipe, and you can just cycle through on your keyboard and within a couple minutes verify each of the pipes in your data set so you can make sure that you're working with accurate data. All right, the next step in making a complete pipe model is capturing any missed pipes from the automated extraction process. And again, we've really refined the tools to enable you to go through and do this quickly and easily. So we have some really fast and easy tools to allow you to select a portion of points that should belong to a pipe and extract them. You don't have to go through and clean up the point cloud in order to make sure you're just selecting the correct points that fall on the pipe. You can just go through and visually, very quickly, go through and just grab the points that you see, and it will make a pipe. So that's the workflow. Once you're satisfied with those that you've got in most of the pipes, you can next do an auto connection routine. I'm going to adjust this so it only gets the most confident connections. You can see all the black pipes are the pipes that the software automatically connected through void regions in the point cloud. And finally, we can clean the pipes, which merges the black and orange sections of pipes together. And now the most important part for the MEP is the ability, this big purple R button here that allows you to open the model in Revit. I'm going to export it right now as pipes and elbows. And the software is just going to launch Revit and then interface directly with Revit to bring that model into a new project. So it's creating pipes, then it'll go through and create the elbows. And this is a new error message that started popping up on my machine just this morning. It doesn't seem to affect the display at all, but I got to talk to Kyle about getting rid of that. Here's the report that comes through when you push the data over into Revit. So you can see that we created 72 pipes successfully, 20 elbows, 3 of them failed. And we're finding that we typically about 20–25% of our elbows are failing right now. So we're working. Hopefully, we'll have that get that number down to where we're extracting 99% completely. Let's take a look at this model that I just brought in. So you can see that if I navigate around, we've got all our pipes. They are true Revit objects. Now, if I click on one of these guys, you can see it's a PVC pipe. It tells the reference level, the phase that it was created, all the diameter information, everything like that comes straight across directly into Revit, and it's a fully functioning Revit object now. Let me do one last thing and bring in the point cloud. I forgot to change it to origin, so let me undo that. Okay, It's very important if you want them to line up that you keep it origin to origin. There we go. So now we can see the point cloud and how it lines up with the pipe data. So that's the workflow now with EdgeWise MEP for Revit. Let me show you one last thing before I get off. And let me show you the placeholder capability. So Revit has this really cool functionality. It's not working 100% right now, but it will be in the next week from EdgeWise. But it occasionally is a little quirky. But it's a great technology that Kyle can tell you a little more about. But it gives you, if you haven't worked with placeholders before, it allows you to work with data on a much more conceptual level before fully rendering it and applying all the attributes. So it's a very flexible format to work with. And I think here's my error message again. Oh, there's a do not show again. I should have clicked that. All right, here's the placeholders. And the advantage is they're very flexible at this stage. We can go through and let me select a set of them, and we can change the level associated with those, and then we can go through after we've edited these placeholders. We can convert them. Let me deselect that. And select them all. And this will go through and convert all of these center lines with their attribute information into actual pipe objects within Revit. So there's the pipe model using the placeholder functionality. So with that, let me go. Kevin, can I get you to go back to the slides?
Absolutely. Just go ahead and hand back presentation to me.
Okay.
There we go. And we are at the Q&A portion of our session, and what I'm going to do is ask all of our panelists to turn their microphones back on, and we're going to get a chance to hit you guys with some questions. And I think, Kyle, you haven't had a chance really to talk much, so I'm going to throw the first question out at you. Question came in: what is Autodesk's strategy towards automated feature extraction going forward?
This is a wonderful question. So I guess in general, the thing to understand for us is our real top priority is for the Revit platform to be the BIM tool of choice for as-built modeling in any context. And since laser scanning is really a prevalent way to accomplish that task, that falls right into that crosshairs. So for us, our real focus in the short term is making sure the platform itself and the engine that we leverage is the best and the brightest, and it delivers the best customer experience in terms of performance and visual fidelity. So when we think about things like shape extraction at the moment falls into what we think of as our partner ecosystem. So the reason why I'm here today, the reason why we worked with the folks at ClearEdge around their development of this tool is we really look to our third-party ecosystem to deliver these types of capabilities. Ultimately, Revit is a platform for building information modeling. And for us right now, as much as we'd like to be everything to everyone, we're really trying to focus around the core capabilities. So we're delighted to see what the folks at ClearEdge have put together, and we're excited about the value it delivers to our collective customers.
Okay, great. And another one for you, Kyle, while you're all warmed up there. Autodesk acquired Alice Labs about a year ago along with their pretty good point cloud visualization software. Do you plan to incorporate the Alice Labs point cloud visualization engine into Revit, and when?
Aha. So I'm going to have to dance around when, because I'm really not at liberty to make any specific commitments at this time. But I can say that clearly the technology that we acquired delivered substantial improvements in performance, visual fidelity, and additional capabilities in comparison to what we natively ship in our AutoCAD and Revit products, which we call our PCG engine, just for those of you who may not be familiar with it. So when we think about those things that I talked about in the previous questions in terms of the strategic focus for our Revit team, clearly the technology brings a lot of opportunity for our customers to have that better user experience. So we're evaluating the best ways to implement that technology in Revit along with many other products. And we look forward to a day that may come where we would ship that capability to customers like the folks on the call today.
Okay, great. Appreciate that, Kyle. And Kevin Williams, next one's for you. It says, currently EdgeWise MEP for Revit only extracts cylindrical MEP objects. What are the plans to extract other objects like square ducting, cable trays, etc.?
Okay. Right now it's very focused on piping, as you can see. It seems to do a really good job there. And but over the next half a year to a year, we're going to be building some really cool stuff for those what you just mentioned there. Okay. The ducting, as well as structural, as well as like cable trays and things like that. And we've got some very, very interesting research going on right now. We recently won a follow-on National Science Foundation grant, so we've got some neat projects underway. I think you guys will be excited to see what's coming down in the future.
Okay, good. All right, and this next one, I think we're going to throw this out to Kelly and Mike. And Kelly, start with you. It's the same question though for both of you. What's the biggest workflow challenge that your company runs into in modeling as-built MEP?
For us right now, it's really our ability to manipulate the point cloud data and extract information and model information from it accurately. I could go into a lot of detail on where that falls apart right now. We don't use Cyclone. We pretty much bring the point clouds into Revit and model on top of it using either CloudWorks for Revit or I guess Imagine It now, their scan-to-BIM plugin. Those have been our older workflows, and it's a pretty tedious process. It just takes a whole lot of man hours. That's the biggest challenge. Just very, very slow and manual.
All right, Mike, how about for you?
I would say that studying and establishing the expectations from the client in terms of how much is going to be modeled. They see these point clouds in the level of detail, so the scope goes from minimal elements needed to be modeled to give me everything. And of course that can be done, but there's a time investment there and a budget there. So I think communicating what can be modeled in the time and the budget that we have is always going to be the challenge for every project. So we try and set those expectations and get as much clarification up front as possible, and that seems to really help.
Okay, great. And Mike, I hope you're going to stick around. I'm just looking ahead at the questions, and several of them are directed at you. But before we dive into those, I think this one I should probably send to Kevin Williams. Kevin, the question came in, will EdgeWise work for AutoCAD and MicroStation?
Yes, it does quite nicely, and those have been working for a while now. Okay. We have direct importers for EdgeWise C3M files for both of those platforms.
Okay, good. And then Mike, I'm going to come back to you. Several questions about your case study. One was just how many square feet was the structure in your project?
187,000 square feet was the project area, if that answers that question.
Yeah, I think it does. Okay. And also, Mike, how much time was spent to clear up conflict issues?
Very, very minimal, actually. I would say for 2 hours of extracting data, maybe 5-10 minutes, and I think I only saw one area that there was a conflict, and it turned out that there's more human error. We moved something inadvertently, so it does a good job.
Okay.
It was very minimal cleanup.
All right, and one more quick one for you. What percentage of piping was automatically extracted from EdgeWise versus completed in Revit?
About 80%. I can confidently say 80% was modeled.
Okay, great. Here's an interesting one. This is for the entire panel. Get a quick survey around the panel. This person asks, what % of current projects are asking for Revit models as part of the initial RFP, and what participation among MEP providers, what do the trends look like? I guess they're just asking you what are the trends right now in the RFPs. Why don't, I imagine, Kyle, do you have anything to input on that? Are you seeing RFPs?
I don't see RFPs as a product manager of Revit. I mean, obviously, we love our product, and we hope that our customers use it as much as possible. But ultimately, it's really a better question for our guys out of the industry right now.
Okay. Yeah. Let's go ahead and ask Kelly. Why don't you weigh in on that first, then?
I mean, since we are basically contracting scans for our own use, it's in that sense it's 100% for us. Everything we want in Revit. But it's, again, we're not a service provider to other AEC firms, so that maybe we may not be the best person to answer that either.
Okay. All right, Mike, how about you? You want to weigh in on that one?
Sure, yeah. I'm seeing an increasing amount of Revit-specific excuse me, requests in the RFPs, upwards of 90% now, and if some cases where you get those clients that aren't quite sure what they need, they just know it's exciting technology and they know it's going to do something wonderful for them and save them all kinds of money, and translation, their competitors are using it, so they got to get on the bandwagon. I talk them into using Revit, and we'll sit down with them and spend a couple hours just showing them how to use the Revit model, and if they want to go back out to CAD, then they sure can if they want. But I try and talk them into using Revit. It's better for our workflow.
Okay. And Mike, here's a techie question. It says, how exactly do you control the element position when you insert it in the Revit model?
Well, I guess understanding what the origin point is going to be, when that's established right up front, then we don't have geospatial coordinates in Revit, which is, of course, coming along hopefully in the near future. So we'll find, we'll create an origin point and match that up with our extraction out of anything that we create, and it comes in the right spot. As long as we have the origin point and the bearing or the angle, it'll come in.
Okay, great.
And the same with the point cloud. That's how we do the point cloud. That's how we match everything up there.
Okay.
And once you do one, the rest of them will follow.
All right. And Kelly, here's one for you. It says, after EdgeWise auto extraction process, and I think they mean QC, is it preferable to finalize modeling in EdgeWise or Revit?
Yeah, the short answer is we're not. I'm not really sure yet. This is we're very early beta testing the tool. I think there are right now there's some advantages to doing that in EdgeWise. Namely, you can use some of the features in there to try and manually extract things that got missed, and there's some tools that are really designed to help you clean those things up pretty efficiently. It's a little bit more of a manual process if you do that in Revit right now. There are some advantages to doing it in Revit as well. My gut is probably it'd be better to clean things up in EdgeWise. and then kind of try and get it as close to finished before bringing it into Revit. But I think ultimately that's going to depend on who's really doing that work. For us, a small core group are going to get trained in EdgeWise and really know how to leverage the software. I think when our architects or contractors end up getting a scan and bringing it in, they'll probably feel more comfortable finalizing it in Revit just because it's the tool they're more used to using. But that's a tough one. It's a really good question.
Okay. All right. Well, that sounds good. And Kevin Williams, we have some questions for you here. What about walls, doors, and floors for a mechanical room?
Oh, sorry, I was muted. Yep, my favorite stuff. We're getting to it. It's not part of the software yet, but we are. We've got some really cool stuff coming out along those lines of specific object detection and extraction, as well as generic structural features like walls. So it'll be coming. It's not there. It's not available yet, but it will be coming.
Okay. All right. And somebody's got a really good question about version of Revit. Do you have to have Revit 2013, or can it be used in older versions?
Yeah, the current version is specific to 2013. And but you can use the building suite or anything like that, but you do need to have 2013 installed. We're debating going back and offering support for earlier versions, but I don't believe, and this is more a question for Kyle, I don't believe pipe placeholders are available in earlier versions. Is that true?
I believe they are in 2012, but not before that.
Okay. Okay. So if that's the case, we probably will be offering backwards compatibility to 2012.
Okay. All right. And Kyle, how does Revit understand the properties of the pipe when it's opened in Revit?
Actually, I believe Kevin is leveraging the Revit public API to create those elements natively using Revit's tools in the background. So it's not that we're actually converting so much as Kevin has done some excellent work to understand the locations of those pipe elements and different vertices to define those pipe elements, and using those vertices with the Revit API to actually create those elements. So Kevin, please jump in here if I've butchered your general methodology.
No, that's essentially correct. With the exception that it was my team really that did it, as opposed to me. So I'll go back and pick their brains, but that's essentially how it works.
Okay. And Kevin, do pipes always import into Revit as PVC? Why not a generic pipe family?
So the placeholders, I'm not a Revit expert, and I actually have fairly limited time in front of Revit. So Kyle, correct me if I'm wrong here, but placeholders essentially do that. The pipes that we export as pipes and elbows right now come in by default as PVC, but they can be changed. But that is just that much more flexible if they come in as placeholders. So you can change them to whatever library or family you have available.
Yeah, so this is Kyle here. I can add just a little bit of background.
Sure.
So, I mean, those are what we call the system family type for the pipes, and that's really just a native setting inside of the Revit project itself. So when Kevin, I mean, you have to think about it. Effectively, what the folks at EdgeWise are doing are running the pipe creation tools in the background, transparent to the Revit user. So just like you can set the pipe type when you happen to create a pipe run yourself, you could do the same thing via the API. So ultimately, if it doesn't necessarily work this way now, it certainly could work this way in the future to present you guys a choice as to what pipe type you're looking for. And that's if you want to natively go straight to piping elements. But as Kevin mentioned, if you transfer natively into Placeholders are effectively a generic system family type, and you can convert those into any system family type that would be available in the actual project. So it's really up to you, the user, to decide how you want to convert those placeholders.
Okay, great. Kevin Williams, here's a really good question, one of these things, maybe we should have explained this at the beginning, but the question is, how is the original scan created? Is it just a photo? I think they're talking about how was the point cloud generated. You on, Kevin?
Oh, I'm sorry, I was muted again. I'm sorry. Everything that we were talking about today was created from laser scanners. Several different types of laser scanners, but it was all laser scan data, and that tends to be the most reliable way to generate a point cloud right now, and most accurate way. But there are certainly some other ways to generate point clouds, including stereophotogrammetry or even videogrammetry. But the vast majority of people willing to create as-builts from point cloud data are using laser scanners.
Great. Somebody just asked a really good question. What's the maximum size of a single data set you can handle at one time?
On our side, I'll let Kyle. We haven't stress tested the Revit side, but on our side, you can run. We've run thousands of scans through the software. So there's really no real limit outside of your hard drive space on the EdgeWise side for how much data you can process.
So just to jump in here, within the Revit product itself, actually probably Kelly's probably a better guy from firsthand experience, but usually there's a number of different factors that would contribute to what we think is the top end. I mean, in reality, Revit doesn't really have a set limit, but of course you can hit a performance limit where it's just unbearable. Unfortunately, there's a lot of different factors that would equate to that, so it's tough to say in terms of square footage or element count or things like that. It's a number of factors in terms of dependencies between elements and densities of elements in a view that will contribute to what most customers perceive as general performance. But I mean, as a general rule, usually people, once you get up to about a quarter, 250 megs in terms of a project size as a general rule, on the architectural side, it begins to hit towards the top end. But again, it's really tough to say in terms of specific metric. But ultimately, I mean, there are limits to the overall scalability, and it's usually on very large projects.
Okay, great. And we just have a couple minutes left. Probably get a couple more questions in. This one I'm going to throw at Kelly and Mike. They're asking about, obviously not all of the pipes are extracted and there are gaps once it goes into Revit. What's the workflow to begin reviewing each run of pipe and closing the gaps in the model? Kelly, why don't you start on that one?
On this particular project, since we'd already created a piece of content in Revit, a family, to basically do it from scratch, we use that same family to fill in the gaps. It's a really pretty simple process to go through and do that. Again, EdgeWise has some good tools to help you kind of connect the dots, fill in the gaps, things like that. So, to go back to the earlier question, I think whenever possible, it probably makes sense to do as much as you can in EdgeWise before bringing it into Revit.
Okay. Mike, anything to add there?
Yeah, and I think what I'll throw in there is I think the new QA functionality that you guys added is probably maybe understated in the value during this webinar. It probably improves our workflow and our confidence level 100%, just because it's so fluid now to be able to go through and check our pipes, make sure they're the right size, and just have that higher level of confidence before we start getting into collision detection and merging as-built in with design data. So it's really up the confidence level there.
Yeah, I agree 100%.
Okay, great. And speaking of percentages, Kevin Williams, somebody wants to know what's the accuracy of features generated?
Millimeters.
It completely depends on the data set, but there are a couple of factors to look at here. The fit to the points is always the mathematically optimal fit to the points, but occasionally it will choose the wrong points. So it will either be dead on or it will be a blunder, and we see blunder rates anywhere from 1 to up to 10%, depending on the quality of the scan data and the complexity of the scene. Usually somewhere around 2 to 3% range are the blunders, but the ones that it gets correct are dead on.
Hey,
Great.
Kevin,
Yep,
can I
go
follow
ahead.
up on that?
Sure.
It has a lot from our experience with the tool, and also kind of being one of the beta testers for version 3. It has a whole lot to do with the density of the scan. A lot of our scans for architectural space are still done using time-of-flight scanners, and we generally find we get much better results out of phase-based scanners just because of the point density. So, if you're anticipating using these tools, I think it impacts which scanner you would ask for your scanning provider or select to use. I don't know if that's Kevin can probably explain.
Yes, absolutely.
Okay. Great. Well, I think that'll have to be the last word because we are out of time, and we are getting a lot of questions about how people can access this presentation, and we are recording it, and we'll send an email out with a link so everybody can review it later in the recorded version. And somebody asked if there's going to be a PDF of the presentation. We will try to get something out to that person, possibly everybody, but we'll huddle after the webinar's over and get that follow-up email together. But I want to take some time to, on behalf of our panelists and our sponsors, Workflow 4.0 and ClearEdge 3D, I want to thank everyone in the audience for joining us today. And as a reminder after the broadcast, please look for that email. You'll see a link to the recording, a chance to subscribe to the newsletter, Workflow 4.0, and there'll be other follow-up information on EdgeWise MEP for Revit. Thanks for joining us.